We are going to do a brief video tutorial on how to run a principal component analysis on a survey. So our survey has 23 different questions, and here they are. This is out of the Andy Field textbook, by the way. So you figure with 23 different questions, are they measuring 23 unique different concepts? Or do some of these questions tend to be measuring the same thing? So that's what principal component analysis is all about. It tries to basically reduce the number of variables that you're going to be using in a statistical analysis. So from these 23 different questions, we're going to try to determine if there are any kind of what we call underlying themes where several of the questions will be answered so similarly that it makes more sense to regroup them under this new underlying theme, something that we're going to call a factor, or it could be called a latent variable. But let's go ahead and do this. I do suggest you download the SPSS datasheet and kind of go along and practice it with yourself as we're making this video. So hold on one second. All right, here's the data sheet with 23 questions. Yes. And let's see what kind of variables they're marked at. We could probably use scale or ordinal is probably as okay as well. And it looks like they're already pre-marked as ordinal, so we'll just go ahead and leave those, okay? So, number one, we're going to check some of the assumptions. Remember the assumptions? So we're going to go to Analyze Descriptives. I always go to Explore. And I want all of them in there. And I want any outliers. So here's the beauty about using a Likert scale, 1 to 5. You probably won't get any outliers whatsoever. And we're going to uncheck that, click the histogram. We want the normality tests and options. I don't think there's any. Let's click OK, and let's take a look here. Before we look at the output, let's go ahead and refresh our memories on what the assumptions are. Assumption 1, all variables should be continuous or scale in SPSS or ordinal, so that one's covered. Linear relationship, we'll check that in a second. Sample size, our sample size is huge, as I recall. Yeah, we got over 2,500, so that's not going to be an issue. Number 4 is that the data should be suitable for data reduction. In other words, some of these questions should be highly correlated. In other words, let's assume question 6, 12, and 19, everybody should have answered those relatively the same. So if they scored like a 5 on that 6, then they should have also scored a 5 on the 12 and the 19, whatever those other ones were. So that's what we're going to be looking for, and we will that's what we're going to run the principal component analysis for to tell us. And in the last one, we're going to check to see if there's any significant outliers. So back to the data sheet. Okay, so explore. Here we go. So again, sample size is plenty. No missing data. Kind of nice. There's the averages and the standard deviations on each one of the questions. Question is called an item in factor analysis, or PCA. All right, here's the normality part for all 23 questions, and look at the significance level, right? They're all less than 0.001. In other words, every question, all 23 questions or items are not normal. All right, the reason behind this non-normality is because the range is pretty crappy, right? It only goes from 1 to 5. Which in turn means that you're not going to have a lot of variance. Again, that means that your standard deviations are going to be very, very small. They're going to be very close to 0. So therefore, that's why we say that it is not necessary for these questions to be normal, okay? Because it'd be very, very difficult for these questions to fit a normal curve. Now remember, assumptions aren't really that important if you're not looking for significance, right? We're not going to do any kind of tests or any kind of inferences or anything with this. We're simply trying to lump the questions together that are being answered similarly. So the assumptions are not that critical in this type of statistical use of data. Okay, I'm just going to go ahead and run the PCA. We're going to go to Analyze, Dimension Reduction, Factor. Okay, everything that we want to run the PCA with, we simply bounce over to the variables. So I want all of them in there. So we're going to check the boxes. Descriptives. What do we want from here? So this will give us the basic descriptives of each of the items, each of the questions, right? The means, the standard deviations, et cetera, et cetera. We want the coefficients box clicked. That's going to produce our R matrix box. That's going to tell us about all the different correlations between all 23 questions. And the significant levels that goes with the correlational coefficients, right? That'll tell us which ones are significant or not. We want the determinant. That will tell us if we're going to violate the multicollinearity or the singularity assumption. And the determinant should be greater than about 0.00001. So in other words, it can't be 0. So the determinant cannot be 0. If the determinant is 0, that means we're violating multicollinearity or singularity, okay? So, and if your determinant is 0, you have to go back to your correlational matrix, your R matrix, and you're going to look for any variables that have a correlation that are higher than 0.8. And then you basically got to get rid of one of them, something like that. So that's what's going on with the determinant. And then we want the KMO and Bartlett's test of sphericity. But because our sample size is huge, I seriously doubt that that's going to be an issue. And I think that's enough for now. We're going to go ahead and click Continue. Go to the next box, which is going to be extraction. This is the important part. Okay, so it's going to ask you which method do you want. And because this is a principal component analysis, we're just going to take the one that says principal components. Bam. Okay, I'm not going to go over the covariance matrix. We're going to keep the correlation matrix. That's using the data as is. So real quickly, the covariance matrix it's the same matrix, but it's been analyzed a little bit differently. So you might get different results. Usually it has to do with some of your questions don't have the same count in them. In other words, what if you had some of the Likert questions that went from 1 to 7 instead of 1 to 5? That's when you might switch to the covariance matrix, but we're not going to do that. So we want the scree plot. That's going to tell us, that's going to show us how many new factors there are, and they're all going to be based on an eigenvalue greater than 1. We could change that if you want, but 1 is a pretty good preset, so we're just going to use that. We're going to click Continue. And since we're just doing a PCA, this is a first step to factor analysis. Principal component analysis, factor analysis, they're cousins, okay? But PCA it just tells you how many new factors, new latent variables you should have, and it stops there. Where a factor analysis will kind of drag out those questions that don't line up very well, where principal component analysis will not. So let's just click OK and see what the scree plot looks like. So here's the descriptives box, which we kind of did earlier in the video, but you could just do them all at once. I didn't realize how easy it is. Let's take a look at that, right? There's the mean scores for each question. There's the standard deviation and how many there were, and there's a lot. So this looks like your R matrix box. It looks at the correlations between question 1 and question 2, question 1, question 3, question 1, question 4, et cetera, et cetera, et cetera. So this is a huge box of data. So what the principal component analysis is looking for, it's looking for questions that are strongly correlated. That's all it's doing, okay? So let's just scroll past this. So here's a couple of assumptions being checked by the KMO. I believe that has to do with your sample size. This statistic, this 0.930, this number should be greater than 0.5. If this KMO number is not greater than 0.5, you probably need to increase your sample size, okay? and here's the Bartlett's test of sphericity. With this, we want this sig value to be less than 0.05. I'll say that again. With principal component analysis, we want the Bartlett's test of sphericity to be significant. And ours is. That means we did not violate any of the assumptions about the spread of the variance of the data. So coming up, the communalities box. So what this is this initial commonality is before the extraction process. And these all should be ones. So in other words, nothing was done with these whatsoever, and they start off with the number 1. But after they've been extracted, the commonality, this number here, this is the proportion of the common variance within a variable. Okay? So in other words, this first question with 4.435, we can say that about 43.5% of the variance associated with that question is common variance or shared variance. Okay, so that means it's loading up with a lot of other questions. Okay, that's good. So this extraction number tells you how well this question is lining up with other questions. And you'll notice they're all relatively good numbers. Okay, you got some real high ones here. There's 0.739. And the good news is there's no low ones. If you had a real low extraction number, that means that one question is not loading up with other questions. It's not being answered similarly to other questions. All right, the next box, I believe, is what we're going to call the money box. Here it is right here. This is your big box, the total variance explained. So we're looking at the new components, right? These are new factors, or what are we going to call them? Latent factors. So the first one, one new factor, one new umbrella term, if you lumped up a bunch of the questions that are being answered similarly, can explain about 31.7% of the variance by itself, okay, which is a lot. So what we're going to do is we're going to count how many components, 1, 2, 3, 4. As long as these are the eigenvalue scores here, remember the cutoff of 1. So any new component with an eigenvalue of greater than 1, we're going to go consider as a new factor. So according to our data here, it looks like out of the 23 questions, we should probably come up with 4 new themes or underlying characteristics to line up which of the questions are being answered similarly. So we're going to reduce our 23 question survey down to just a 4 variable survey. And with those 4 new components, those 4 new factors, we will be able to explain a total amount of about 50.3% of the variance. So with the 4 new components, we're going to be able to explain about half of the variance. And going down to our scree plot, that should basically agree with the box that we just looked at. But again, so we're only looking at, these are the eigenvalue scores. So the first component is way up there. It's about 7. The second one is about 2. You see this immediate drop off here? So that means your first new component is going to have more questions lined up underneath it. And so we go to 1, which is right about here. So 1, again, it agrees with this box that says we should probably make 4 new components. That's what that's saying. Okie dokie, let's finish this bad boy up. There's our scree plot again. So this tells you, out of the 4 new components, this tells you how strongly each question loads up under each of the new 4. So usually it works like this. The bigger the number, that's probably the new component it should go under. So question number 1 should be under component 1. Question number 2 looks like component 2. Question number 3 should go under 1. Question 4 should go under 1, etc., etc. In fact, I'm looking at most of these. Most of these will load up under number 1. Okay, that's probably why when we looked at this box, our first component can explain about 31.7% of the variance by itself. So you look at these other changes, these other components, they don't add a lot. The second component by itself is only about 7.5%. The third component's only about 5 1/8, and the fourth component's only about 5 1/3 or something. Okay, so it's not a lot of change. If I was doing this, I would probably keep just the first two components and kind of get rid of the other ones because they're not adding a lot to your predictive model. That's what I would look at. Let's see what else we got down here. So again, this just tells you which question gets loaded up under which of the new components. And that's basically it for a principal component factor. Again, it just shows you which questions line up together under the new components. That's what principal component analysis does. So we're going to make a second video to show you how to run a factor analysis. And again, what the difference is the PCA, what we just finished, just kind of illustrates how many new factors you should have and which question should be under new factor. Where a factor analysis, it's going to weigh how much influence it has, how much variance it can explain, and if it doesn't reach a specific amount, it's gonna pull that question out of the rotation, right, out of the pool. But that's it for now. MGZ out.
测试，我们要做测试，好好玩哦！大家新年好，过年快乐！哈哈哈哈。
Ah, the little fox runs.